Hello, Farouk here. This is the third video in a series on developing JavaScript Azure functions. In this video, we will add an HTTP trigger function to the project we created in part 2. Adding a new function to an Azure function project is easy. I go over creating a function project in part 2, so watch that video if you don't have a function project created at this point. In VS Code, click the Azure button, then click the Create Function button. Select HTTP trigger, provide a function name, select an authorization level. I will select function, and here is the function. Now that we've added the function, let's go over the project file structure again. Each function is placed in a dedicated folder. Our newly created function is in the My HTTP trigger folder, because that is what I named the function. Index.js contains the function code. I recommend that you do not rename this file. Function.json contains the configuration metadata for the function. Function.json is an important file, so let's talk more about it. Function.json contains the configuration metadata for the function. Specifically, it contains the function's bindings. Having developed .NET functions, you should be familiar with bindings. Whereas in .NET functions, bindings are specified via attributes in the C# code, they're specified in function.json in JavaScript functions because JavaScript does not have the concept of attributes. Some of the binding information found in function.json is the function's authorization level, the binding type, the binding direction, and other binding information based on the binding type. Here is our newly created function's function.json file. There are two bindings, one input and one output binding, per the values of the direction attributes. The input binding is an HTTP trigger binding. The name attribute is set to REQ. This is how the binding should be referenced in the JavaScript code. The methods attribute is specific to the HTTP trigger binding type. Here, the trigger supports get and post methods. The output binding is an HTTP binding, which means the function returns an HTTP response after it executes. The name attribute is set to RES, which is how the binding should be referred to in JavaScript code. Now let's take a look at the JavaScript code in index.js. Line 1 declares the function entry point. Just take it as a given that every JavaScript function will begin with module.exports equals async function followed by a context object as the first parameter. Since this is an HTTP trigger, we have an additional parameter, REQ, that represents the input HTTP trigger binding. Note, the name here must match the name specified in function.json. And the order of parameters is important. Context must be the first parameter passed in, and the request or the input binding must be the second parameter. The context object gives you access to the logging system via the log method. The context object also gives you access to bindings. Take a look at line 5. This is where the 200 response is returned. The response object with the name RES is the output binding. On line 11, the output binding is set to return a 400 response. Of course, the output binding does not have to be an HTTP output binding. It could be a blob storage output binding, for example. The request object, REQ, contains two important sub-objects, query and body, as shown on line 4. Query contains the query parameters, if any, passed to the function. Body is the request body, if any, passed to the function, as might be when sending a post request. Here we see that the function either expects a query parameter named name or a body having a JSON attribute with the name name. If neither of those are found, it will return a 400 bad request. Let's run this function. Click the terminal menu and select New Terminal. Type func host start and enter. Here we see that the function app has loaded the HTTP trigger and it is listening on this URI. Let's call this function using Postman. Postman is an IDE that makes it easy to work with REST APIs. To install Postman, go to getpostman.com, click Get Started, then click Download. Run the setup program with all the default options. Here I have Postman opened. To call the function, I need to create a new request. So to do that in Postman, click the New button, then select Request, and give the request a name. And then you must create a collection to put the request in. A collection is Postman's way to organize requests. Click the check mark button, then click Save. So now the Request tab opens. I'll keep the method as get and enter the function's URI as shown in the VS Code terminal window. The function expects a name parameter, so let's add that. Click Send, and we get a 200 response and a response body that says hello. The function is working. If we go back to VS Code terminal window, we can see additional logs are written. We can easily debug JavaScript code in VS Code, so let's do that. Terminate the function app by typing Control-C in the terminal window, followed by Y, and then enter. We are back at the command prompt, which means the function app is not running. Let's clear the terminal window. Now let's set a breakpoint on line 16. Click the Debug menu, then select Start Debugging. The status bar on the bottom turns orange, which means VS Code is successfully attached to the node worker process. Let's call the function from Postman exactly as we did before. And the breakpoint has been hit. Here is the locals window in which we can examine the context object. We can see that the context object does indeed contain the bindings REQ and RES. We can add a watch to see what the request.query object looks like. And it has the value of her name, which is Farouk in this case. We can also see what the response.body looks like. There you go. I find it amazing how easy debugging JavaScript functions is in VS Code. Click the Debug menu, then click Continue to resume function execution. If we look at the terminal window, we see the same output as we saw when we ran the function without debugging. Thanks for watching.